Hello world! My name's Iain Duncan, and I am the author of Scheme for Macs. Scheme for Macs is an open source external for Macs MSP that enables us to script and live code Macs with Scheme Lisp, specifically S7 Scheme from CCRMA at Stanford by Bill Schottstaedt, which is the same one used in the SND music editor and also the Common Music Algorithmic Composition Toolkit. Today we're going to look at what's new in version 0.2, which has just hit beta. So we have releases up for both Windows and Mac, and we are ready for testers. And it's an exciting release because it now includes algorithmic composition support and working with the Mac scheduler, making it possible for us to lean on all the great contributions in the common music world by Rick Taube. Okay, let's take a look at 0.2. Now quickly, the first major feature, well, if you're not familiar with Scheme for Macs at all, I suggest you go and watch the version 0.1 starting video so you understand what it's all about. And in this one, we'll just look at some of the new features. Now, one of the first things that is new is that the Scheme for Macs interpreter now runs in either the high or the low priority thread only. We can lock it into either the scheduler thread or the UI thread. And this enables us to do timing critical real-time tasks, as well as sequencing and delay functionality. And it's something that's not possible with any of the other options in Macs MSP right now, because the JavaScript object only runs in the low priority thread. So any jitter in the low priority thread is going to wreck the timing. And the Node for Macs object runs in a separate process, so that really can't do it either. So that's a big rollout in this one. In addition, we also have a couple of high-level features, some attributes to make it easier to turn on and off the logger. So log REPL means that things either do or do not get logged to the console, and log null means that the empty list does or does not get logged to the console. And in this particular video, I'm also demonstrating a new way of working with it that I've cooked up using gvim as my editor. So of course you can still use the built-in bpatcher, and you can send messages to the Scheme interpreter just from normal Macs messages. But what I'm doing here is I've got an OSC listener that takes input from my Vim buffers. And I put in some key remapping, so if I'm on a Scheme expression, I can simply say "E", and it is going to go over the network into the interpreter, and we can see it in the console. Now, in addition, I've also got a OSC listener here running in a terminal just to give us a bigger font, because the console font is not actually growable on OS X. This one is a little sketchy though. Sometimes it takes a while for messages to show up. So it's just for the purpose of the video. This is a really nice way of working because we can now create functions, for example. Let's have it output, say, keyword foobar, out 0. And we can see right now I've got the REPL turned on, so the return value of defining the function is the symbol for the function. That's showing up on our REPL. And now if I want to call it, I can just treat any line I want like an interactive REPL. And there we go. Now let's also talk about what else is new in the release. We'll just give you a brief overview and then I'll go into more detail in subsequent videos. We now have direct table and buffer access. So that means we can write and read to named tables for integers and to named buffers for floats. We can use multiple channels on the buffers. And this is very helpful for having a data structure that can be shared between Scheme for Macs interpreters. Perhaps you have a number of them with different tasks, or you have one in the high priority thread and one in the low priority thread, or shared with just regular components in Macs. We also have the same input and output functions now for dictionaries. This is similar to the JavaScript dictionary support. So we can read and write to named dictionaries, and we can recursively load up values or set values in those dictionaries. Nested arrays will become scheme vectors and vice versa, and nested dictionaries become scheme hash tables. And this includes functionality to do recursive setting in the dictionary. You can send a list of keywords and it will trace through the tree of the dictionary to get the value you want in just one function call. In addition to that, we now have interaction with the global transport. So we can start and stop the transport, query its state, find out where it is, seek it to different points, set the BPM, set the time signature, and we have a library of helper functions for converting between different time values in sync with the transport. So for example, if you want to find out what the milliseconds is for a quarter note value according to the settings of the current transport, that is now supported. And most excitingly, we have the scheduling functions that make algorithmic composition and real-time sequencing reliable in Scheme for Macs. So we have two varieties of those. There are the delay functions. We can delay a Scheme function by a millisecond value or by a max musical time notation, like the 4n, 8n, or by a number of ticks. And we can do those in sync with the transport and quantized to the transport. So if you want to delay something but have it fire perfectly aligned with the quarter notes of the transport, that's supported. And the second version of that are the clock listeners. Now we can set up a repeating clock so that one of our Scheme callbacks is fired every X milliseconds or every X ticks. And again, these can be quantized and synchronized with the transport. So that makes it possible for us to build sequencers on the fly and to do algorithmic composition functionality, such as having a function reschedule itself and set off daisy chains of functions that perhaps mutate their data while also reading to and from global data if you want to interact with them that way. So that's a brief overview of what is up in version 0.2, and we'll be covering the various components of that in more detail in subsequent videos. Thanks for watching.